In this video, we will learn how to visualize categorical data with Seaborn. Similar to visualizing numerical data, continuous data, using relation plot and the other plot, Seaborn also offers a main function called catPlot for categorical plot, which we can customize by entering the parameter kind. Seaborn also offers a custom function name for each one of these different types of the graphs. This enables us to use the general function and then fine-tune the kind of the plot, or if we're kind of settled on what we want to do, we can use immediately the categorical plot that we want to visualize. In terms of the types, we have three main types. We have categorical scatter plots, which basically visualize the relationship between two variables. One of them is categorical. Categorical distribution plot, which visualizes the distribution of a numerical variable over different values of one other categorical variable. And then categorical estimate plot, which basically show the relationship between two variables. One of them is categorical with some estimation or extrapolation of that general relationship. So let's take a look at each one of these different types of categorical plot. Let's first take a look at categorical scatter plot. So remember when we created scatter plot with two numerical variables, each variable was represented by one axis, the x and y. And that's basically the same idea when we have two variables. One of them is categorical and one of them is numerical. The only issue in here is that because the categorical variable, the value is set, if you don't introduce any custom processing of the data, it's going to show exactly on one one line on that axis. For example, let's take a look at this example where we are visualizing the tips data set. So we've got the two variables, day and total bill. If we visualize this relationship between the two variables as a relation plot, all of those points in each day are going to be exactly on one line, and hence it becomes very difficult to see the different data points in here. And hence if we're using catplot, Seaborn is going to add some jitter, and that jitter means some random noise, just basically to make the data point kind of further between. So the syntax is catplot, and then we map the x and y axis to the two variables in the data frame, and then we pass the data frame as the data parameter. Now let's see what happens if this jitter parameter is turned to be false. Without jitter, as you can see here, all of these points are kind of aligned, which kind of is okay for small data sets, but if your data set has been large, you're basically going to see lines here, and probably the main useful information will be the minimum and the maximum spread, but it won't be easy to see the distribution of the data across these different values of total bill. For example, we see that most of the data points are here, for example, when it comes to Thursday. If it has been one line, it won't be possible to see that distribution. Now, in addition to that basic visualization of the categorical plot, Seaborn offers two different ways to make this plot more interesting. The first one is what it calls the swarm plot. This basically, on top of adding that random jitter, it actually goes ahead and arrange the data points to show the distribution of these different data points across the different values of the numerical variables. So it's kind of like creating a histogram, but it's not a histogram. It basically will align these data points together in a swarm kind of shape. And the main idea here is that the thicker this spread in between the points will illustrate kind of the density of the concentration of the data point across these values range. So if we do this, we can see that most of the tips on Thursday are in between 10 and 20. When it comes to Saturday, for example, they go from 10 to a bit more than 20, right? So that kind of gives us also an idea of the distribution of the data points. Now, you can see that we passed in kind is equal to swarm because by default, if we don't pass it, we're going to get the default visualization here. All right. Now, in addition to the basic syntax of the plot, we also have access to other options, such as mapping the hue or color to another variable. So in this case, we mapped hue to sex, and that basically will show us the distribution of tips, the total bill per day, and also per sex in this case. Right, so that's another kind of degree of freedom here to show another variable in the data using color, right? We can do the opposite here. We can say, for example, why don't we put y to sex and hue to total bill, and that's going to give us, oh, sorry, hue to bill, right? And that's going to give us another, sorry for that, another way of showing this plot. Right, so if we see the distribution of tip per male and female here, as you can see here, but we also see the different color mapping by day. So that tells a different story, right? Here the main story is, you know, whether men and women, you know, tip differently. All right, so let's go back to the original formulation here and move on to talk about some of the other nuances. Now, one of the issues when you have categorical variable is that the ordering here really depends on how the data is ordered in the original data frame. So really it becomes important to set that ordering properly because otherwise you may get like an order which doesn't make a lot of sense. For example, here we see that we've got the correct order: Thursday, Friday, Saturday, and Sunday. And this is because the data frame has been carefully ordered. If you take a look at the data types in the data frame by accessing the attribute dtypes, actually it's tips here. Let's check again. Data equal to tips, dtypes. We're going to see that day is actually of a categorical type. So if we look at tips.day, you can see that the ordering in between those different categories has been also entered in the data frame. If this is not the case, we can also impose our own ordering. Now, by default, Seaborn is going to use the natural ordering of any data that can be sorted. So in this case, if we do a categorical plot with x equals to size and y equals to total bill, size here is going to be sorted from 1 to 6, which is kind of the natural ordering. We also have the options of putting our own ordering on the data. So let's take a look at this example here. So let's say we want to visualize the tip by the category smoker, yes or no. By default, we're going to get yes and no, which is the default because this is how the data has been ordered in the data frame. If we take a look at tips.smoker here, you can see that that's the order that the data has been stored in the data frame. But let's say we want to change that order to no and yes. So if that's the case, we can enter the parameter order and we specify the order of those categorical variable. And here we are arranged it by no and yes. We can also flip the x and a y, and in this case we get an opposite figure, which can be useful in some situations, especially if the spread is larger on the numerical variable than on the categorical variable. So that would be useful to save space on the web page or the paper if the report is to be printed out. So in this case, we just flip the x and the y axis to get a horizontal swarm plot. Alright, so let's take a look at the second way of creating visualization of data that has categorical variables. Say, for example, we are interested in looking at the distribution of one variable per the categorical variable. And this is kind of what we've done here with the swarm plot. The swarm plot is designed to reflect a bit on the distribution of the data. But there are plots that are kind of more geared towards showing those distributions. And one of them is the box plot, which is a plot that you've probably seen in statistics. This is one of the most common plots for visualizing distribution of variables across categories. Or even if we don't have categories, just one numerical variable distribution can be represented with a box plot. It's such a famous plot and was among the first statistical visualization that it has its own Wikipedia page that you can check. Basically, the box plot will take one variable and map it to a box and whiskers, right? So we've got a box and we get two whiskers and we got points. So what are these? So if you take a look at the box, the boundaries of the box go from the first quartile to the third quartile. And the line in the box maps to the median. So just to remind me quickly, a median is the data point that splits a certain variable to two parts, two equal parts in terms of distribution. So it is the value where half of the observations are below it and half of the observations are above it. Similarly speaking, you can look at quartiles. The first quartile is, you can think about it as the data, the point in which 25% of the observations are below it and 75 are above it. And vice versa for the third quartile, in which 25 of the observations are above it and 75 are below it. So those basically will show you kind of where the data is concentrated. But we also got, spread, and the spread can vary depending on the distribution of the data. And to show the spread, we have whiskers, and the range in the whisker here. So the range in between the first quartile and the third quartile is called the interquartile range. If you multiply that range by 1.5, you've got this representation, the whiskers. Basically, those are observations kind of laying in 1.5 times the first quartile and 1.5 times the third quartile. Now, if you've got really extreme observations that kind of lie really even above these different two different whiskers, then those observations are shown in just simple points, as we can see here. So this basically tells us where most of the data is concentrated and where most of the data is spread and where the few outliers are in our variable. And in the case of Seaborn, we can do this per categories. So in this case, we've got x equals today and y is equal to total bill, and the kind if is box plot. Without x equal today, we can see that we've got one box plot for the variable total bill. So that shows you the distribution of the tips in this data. What's nice about cat plot is that you can do it per category. So we can do it per day. So in this case, we can do it per day, and we've got the different box plot for each one of the day. So what we can see here, for example, is that if you just look at the median, Friday is the lowest in terms of median, but then Thursday follows, but Thursday is kind of the smallest in terms of where most of the data is concentrated, right? And that concentration spreads out, especially across the weekend, where you have also a lot of outliers. Now, similar to the other plots, we can add another variable and map it to color using the hue parameter. So in this case here, we are mapping hue to smoker, and we can see the box plot per day per category smoker here. In this example here, we're looking at the distribution, the same distribution, but we're also mapping the color of the box to the variable weekend, true or false. Now, in contrast to the previous example where for each day we've got smokers and non-smoker, here we don't have per each day values for a weekend or a weekday. So if we do just the basic and map hue to weekend, we're going to have some empty placeholders here for Thursday and Friday for each day, because Seaborn is going to assume that maybe Thursday there is also values for weekend is true, but those values don't exist in the data, but theoretically they may exist, which is not the case. Here we just want to map the box color to weekend true and false. So we have to tell Seaborn that we don't want to do dodging, and that basically saying that those two categories exist for each one of the values of the x-axis. So we need to turn to false to kind of to show up the box plot without leaving those empty places. So that was basically the main box plot. And again, this is a popular statistical visualization because it was among the earliest ones to come. And it was among the earliest ones to come because it's easy to produce. So in the past, like decades ago, producing these charts was really expensive, and imagine it or not, many of these plots were created by hand. So hence, it was really important for the plot to be able to be produced. And the box plot is really easy because you just need 5 numbers and some comparison for the outliers to be able to create the plot. Obviously, this is not a limitation today, and hence we have more advanced visualizations. An extension of the box plot is called the boxen plot, which is really similar to the box plot, but we've got some kind of a different size of the box depending on the distribution of the data. So we need to turn on the kind of the box to boxen. In this example, we're working on the diamonds data set, and we're visualizing the distribution of the price of the diamond per the color. So here we will also sorted the data per color so that we get the color here sorted out. Otherwise, it will be, the same order it appears in the data frame. What we're getting in here, we're getting something very similar to a box plot with a basic box, but then we got kind of shapes here to illustrate kind of the different concentration of the data. And even kind of a more advanced way to do the distribution is to show that distribution of the data in kind of like a smooth histogram. And that's basically the idea of violin plot. So violin plot will actually run a kernel density estimation to basically estimate the density of the data in a continuous manner across each cut point in the continuous variable. So that's basically the same box plot that we created really above. So that's the distribution of the bill per day, per sex. I think above we did it by smoker, but it's the same idea. If we turn it to violin, what we're going to see here, we're going to see that we've got kernel density function used to smooth the distribution here. Let's do it boxen here. That's the first change, and then violin is going to smooth those areas here. So we got like a kind of a density estimation plot, similar, something similar to a density estimation plot for each one of these categories. You can also provide some more parameters and option to kind of modify how the kernel density estimation function behaves. But this is something more advanced than what we're looking here, but it allows you to control kind of the fine granularity of that estimation across different parts of the continuum. Something interesting about it, similar to what we've done in the previous example when we looked at using color, right? Using color basically produced a different violin plot for each sub-value here. Instead of doing this, we can actually split the violin in half, and that even kind of condenses the data even more and allows us to compare and contrast the distributions much more easily. For example, if you look at Thursday male versus female, you can see that on average prop male pay more, but the spread is kind of equal in between men and women. But if you look at Friday, you can see that women actually pay a bit more, but the spread is narrower than men when you get to kind of more spread. There are more options for to each one of these plots, including variant plots. This one also allows you to show some individual observations on the distribution visualization. So I'm going kind of to go ahead and talk about the last category of these plots, which is statistical estimation within categories. So those kind of visualizations are useful because they allow us kind of to create a visualization of some of the descriptive statistics that we produced in numbers. For example, let's say you want to visualize the averages of a certain variable. A natural way to make that visualization is using bar chart. So let's take a look at the Titanic dataset, which is a dataset summarizing the unfortunate demographics of the passengers of the Titanic, and the main outcome variable that this dataset contains is whether the passenger has survived or not. So this is a binary variable. If you take a look at the data here, let's take a look at the Titanic data, which is a big dataset actually here. That's the main variable we're looking at as outcome, survived, which is binary 0 or 1, right? And we've got some numerical and some categorical variables here. In this visualization, we're looking at the average of survive per sex here. We also added the class as a hue. Let's skip this for now. And that's going to give us a basic bar chart. The basic bar chart is going to show us the average of the variable survived per male and per female. Right, so the statistical value here is the average, and that's the visualization for the average. This kind of little tick here represents the confidence interval among the average across the value, the statistics, which is average here in this case. Again, similar to all of those visualizations in Seaborn, we can add another layer, another variable by mapping it to hue or color here. Now let's say you don't want the average, you want to do something else. If that's the case, you can also kind of say, I want the count. So instead of doing kind of bar, we can do kind of count, and that's going to do the count. So we're going to count the number of observations, number of passengers in this case, per deck. And we've added another variable for the palette, but basically that's going to give us the count of passengers for each one of the decks of the Titanic. And yet again, we can add another a variable here by mapping it to the color variable. So we can do the passengers per deck per class. That basically shows us that the first class passengers were mostly concentrated in A, B, C, and some of them D, and the lower class passengers were mostly concentrated in E, F, and G. Alright, so the last one is a point plot, and this is basically very similar to a bar chart, except that instead of showing bars, you're gonna see a line extending in between the two bars. So let's do the same as the first chart, in which we've got a bar chart, and we've got the two bars. So let's do this again. To show them one after the other. That's the bar chart, right? So for male, the 3 values of male, you get the 3 values of survived, right, and female. Now instead of doing this, if you do a point chart, you're gonna get the 3 values, the averages per male, per first, second, and third class, and the average for female, first, second, and third class. But what's interesting about the point graph is that it's going also to connect the dots, and that's going to show you kind of a relationship. So what we can see in this graph is that female across the board had a higher likelihood of surviving than male passengers. But that likelihood was kind of more acute for the second, and then the first, and lastly the third class passengers. We can add more nuances to these plots. So those are some of the more advanced applications, for example, such as customizing the line style of the plot. And we can do some of these customizations using Seaborn. Last but not least, we can also ask Seaborn to assume the data is in a wide format. So a long format is a dataset in which each variable maps to a column in the data frame. A wide format data, in contrast, will assume that the columns themselves are the categories. So let's take a look at the iris dataset here as an example. In this iris dataset, we've got a couple of variables here about flowers. So measuring flowers, we can measure the sepal length, sepal width, petal length, and petal width, as well as classifying the flower across one of 3 different species in the case of this dataset. So let's say for the sake of this example that we want to create a box plot to show each one of these variables, sepal length, sepal width, petal length, and petal width. The problem here is that we're kind of limited to creating one categorical plot at a time. So if we create using the default orientation, which is long data, if we create a box plot, we're kind of here forced to specify the variable that we want to operate upon. So we can say, for example, here x is equal to sepal length. Which is fine, except that, say I want to do that across all of the different variables in the dataset. That's not going to work here because those variables were put side by side. This is a wide format dataset. To put it in a long format, we need all of these to be stacked one on top of each other, and another variable here to say what kind of variable is this. You know, sepal length, sepal width, petal length, and petal width. So that's a transformation that we need to do either using pandas or instead actually Seaborn allows us to give kind of a hint that I want to use this data as a wide format dataset. So we just pass in the parameter orient to be horizontal, and in this case each one of the numerical variables is going to be treated as a category. Alright, so we have more options to actually use dataset which is not a data frame, such as arrays, and also more options to control the style of the plot. So those things I'm not going to kind of spend a lot of time on them. You can refer to the notebook or the documentation for more information. The one last very useful option we have with the plots, which is the same actually with catplot as relation plot, is using faceting. And a facet, if you remember, is basically repeating the same plot but for a different subgroup of data. So for example, let's say you want to show a swarm plot of total bill per day, but you want to do it for 2 different times, lunch and dinner. So we can actually use hue and mapping it to either lunch or dinner, mapping it to the time variable, except that we used hue for smoker. So we kind of consume this color channel. And that forces us to use another channel, and one channel we've got access to is faceting, either by columns or rows. So we can actually create 2 columns, one for time equal lunch and one time equals dinner, by mapping the column parameter here to the time variable in the data. That's going to create a facet per column. We can actually do it per row, and that's going to create a facet per row. Right, and we can actually do it in 2 variables, row and column. So like I can say column equals to smoker and row equals to time, and that's going to create 4 facets here. So that's kind of going to that basic idea that we've got multiple channels that we can benefit from, and we can map these channels to the different variables in our data to customize the visualization, the chart. And obviously faceting has more options than that, and again you can take a look at some of these options in the tutorial or the documentation of Seaborn.